Hello everyone, welcome to Sulekha Physics classes. It is the most easiest way to learn all the concept of physics through this class. Today I am coming with one more part of chapter motion. In this part I will discuss how to derive equations of motion using graphical method, right? In the last class we had discussed about graphical representation of motion. It means how motion can be represented with the help of graph. And with the help of that representation of motion, I will derive equations of motion using that one. So, first, what do you mean by these equations of motion? What is this? Actually, when we discuss about motion, there are different terms related with motion like displacement, velocity, acceleration, all these changes with time. So, there are three sets of equations which establish relation between these variable physical quantities. Okay, and that sets of equations are called equations of motion. So, you can write that equations of motion is a set of three equations. It is a set of three equations which establish relation between first displacement, okay, second one is initial velocity, then next final velocity, then acceleration, and then last time. Okay, so there are three equations which establish relation between these physical quantities: displacement, initial velocity, final velocity, acceleration and time. All these quantities are related with motion. So, what are that three equations? That is called equations of motion. So, three equations of motions are first one is V equal to U plus AT. This is first equation of motion. V is what? Final velocity, right? Final velocity is represented by V. U is what? Initial velocity. It is represented by U. A is what? Acceleration, right? And this T is time and displacement is represented by S. So, first equation of motion is V equal to U plus AT. Second equation of motion is S equal to UT plus half AT square. S is displacement here. And third equation of motion is V square minus U square equal to twice AS. All these three are equations of motion, and these are nothing but relation between all these physical quantities: displacement, initial velocity, final velocity, acceleration and time. Now, today's main aim is to derive these equations with the help of graph, right? So, to derive these equations, I consider velocity time graph, right? In which a body moves with uniform acceleration. So, let us derive all these equations one by one. Okay. So, let us first derive first equation of motion V equal to U plus AT with the help of graph. First one, v equal to u plus at. So to derive this equation, let us consider a velocity time graph, right? This side velocity in meter per second and this side time in second, right? This is x-axis and this one is y-axis. And to establish this relation, here initial velocity, final velocity and acceleration, all these things are there. So we consider a velocity time graph moving with uniform acceleration. Uniform acceleration means velocity changes by equal amount in equal interval of time, so that change in velocity is always constant. Okay. So in this case, okay, there are two graphs. One, when a body starts with this zero velocity and it moves in a straight line. But here, initial velocity is 0. But I want initial velocity in expression. So I consider velocity time graph, okay, which has some initial velocity. And suppose this is O point and this one is point A. Now the body starts moving with uniform acceleration from this point. Uniform acceleration means graph is a straight line. So up to this point, a body has initial velocity u, okay, and from here the body reaches to final velocity at this point B, okay. At this point B, the body has final velocity v, right? So this AB is a straight line and it represents motion of a body under what? Uniform acceleration. So how you derive this equation v equal to u plus at? After plotting this graph, I want acceleration here, and you know that slope of velocity time graph gives what? Acceleration. So let us find slope. To find slope, you draw from this position one perpendicular on the time axis, right? Suppose A, B and this point is C. Again, the motion is represented by this straight line AB. So you draw a line parallel to this time axis and take this point as D. So this slope of this straight line AB gives what? Acceleration. So you have to calculate the slope of this graph, right? AB straight line. To calculate that one, first this up to B point, the body has final velocity v. It means up to this point, the body has velocity v. And up to this A point, body has initial velocity u. So here you consider initial velocity u, right? So this whole BC is v and CD is u. Then BD becomes what? This BD becomes, whole is v minus u. This BD becomes v minus u. And from 0 up to time t. So this distance is what? T minus 0 means t, right? Now consider slope of straight line. AB, and it gives what? Acceleration. And slope is what? Y-axis by x-axis in this triangle ABD. Y-axis is BD and x-axis is AD. So BD by AD, and this slope is what? Acceleration. So you can write acceleration A equal to BD by AD. And what is the value of this BD? Change in velocity v minus u. And what is the value of this AD? This is time. So from here you just take v one side, A into t right? Okay, you write first v minus u equal to at, and then you get v equal to u plus at, right? So in this way you derive this first equation of motion, v equal to u plus at. Here acceleration is involved, so you must remember that to derive first equation of motion you always take slope of this motion, straight line AB, because only slope gives acceleration of the body, and in this way you derive this first equation. Pause it and write down. Okay, after this I am going to derive second equation of motion. Okay, hope you have written. Okay, now second equation of motion. Now second equation of motion. What is second equation of motion? It is s equal to ut plus half at square. Now how you derive this one? With the help of graph, right? Here this displacement term is there, s is displacement, and you know that to find displacement in case of velocity time graph, what we have to consider? Area under this velocity time graph, because in the last class we have discussed that area under velocity time graph gives what? Displacement. So this is the motion of the body from O to A. It has initial velocity A, u, and after that it reaches to B point, which has final velocity v. So this straight line represents motion of an object, and under this straight line this represents area of the velocity time graph of this straight line. Okay, and this becomes what? One trapezium. So this area under this trapezium OABC gives displacement, and in this way you can derive this equation s equal to u plus ut plus half at square, right? So area under velocity time graph AB is what? Area of this trapezium, this shaded portion, right? Area of trapezium. Trapezium, you know the trapezium, you studied in mathematics, right? OABC. This is trapezium, which has two parallels, one parallel sides, and distance between them is perpendicular distance, right? So this area gives what? Displacement, right? So displacement S equal to area of trapezium OABC, and this trapezium consists of this triangle ABD and this rectangle, right? OADC. So you can write here area of trapezium is area of triangle, which triangle? ABD plus area of this rectangle, right? Area of rectangle OADC. And you know that area of triangle ABD is what? Area of triangle is half base into height. So half, what is base here? ABD. AD is the base and BD is the height. So half AD into BD plus area of rectangle, this one, length into breadth, it means OA into OC. Okay, you put the values of these AD, BD, everything. What is AD here? AD is time and BD is V minus U. So half AD is T into BD is V minus U plus OA. OA is what? U into OC. OC is what? T time. Right? This becomes half into T. From first equation of motion, V minus U is what? What is first equation of motion? V equal to U plus AT. Here, V minus U is what? It becomes AT. So, you put the value of V minus U here. In place of V minus U, AT plus UT. So, it becomes, you take UT this side, UT plus half AT square, right? And this is displacement S. Okay. In this way, you derive second equation of motion S equal to UT plus half AT square, right? And you must remember one thing, that to derive this equation S equal to UT plus half AT square, you always take area under this velocity time graph, because only area gives displacement S, right? In this way, you derive second equation of motion. Hope you understood this one. Pause it and write down in the copy fast. Okay. Now, after this, one more equation, that is third equation of motion. And what is that one? Now, third equation of motion. What is third equation of motion? It is V square minus U square equal to 2AS. Okay. Again here displacement S is present. So to find displacement in the same figure, again you have to find area under this velocity time graph, right? So again area under velocity time graph AB is what? Area means area of trapezium. What is the name of trapezium? OABC. You studied this trapezium in mathematics now. Trapezium, in this trapezium is those figure in which one side is parallel and there is perpendicular distance between them, right? So, area gives what? Displacement, right? So, displacement S equal to area of trapezium OABC. What is the formula for area? Sum of parallel sides into perpendicular distance between them. So, you can write area means half. I am writing the whole formula. Sum of parallel sides, okay, into perpendicular distance between parallel sides, between them, okay. So, what is sum of parallel sides? OA and BC. It becomes half OA plus BC. Sum of parallel sides into perpendicular distance between them. What is perpendicular distance? These parallel sides. Either you can write AD or OC. You can take anything. Both are same. AD is also T and OC is also T. Right? Now you put the values of these things. OA. OA is what? U. BC. BC is what? V into AD. And AD is what? T here, right? You get this S equal to half U plus V into T. Now again using first equation of motion, you put the value of T here. This is first equation of motion, V equal to U plus AT. So V minus U equal to AT, and here T equal to what? V minus U by A. You just put the value of T here. Half V plus U into T is what? V minus U by A. And you know A plus B and A minus B is what? A square minus B square. So V plus U into V minus U is half V square minus U square by A. This is A. And from here, this 2A multiplied by this S, it becomes V square minus U square equal to 2AS. Okay. In this way, you derive this third equation of motion from the same figure by finding area under this velocity time graph, right? That is area of trapezium. Directly use the formula for area of trapezium. You get this equation V square minus U square equal to 2AS. In this way, we can derive this third equation of motion, right? Note down. Okay. After this, I am going to solve one or two examples from an Ncert book based on these equations of motion, right? Okay. Okay, first Ncert example, page number 108. Page number 108, right? Example number, this one, 8.5. Okay. In this example, it is given that a train starting from rest attains a velocity of 72 km per hour in 5 minutes. A train is initially at rest and it moves with velocity 72 km per hour. It means in this question, initial velocity is given 0 and final velocity is 72 km per hour. In how much time? Time is also given 5 minutes. Okay. Now, assuming that the acceleration is uniform, find the acceleration and the distance travelled by the train for attaining this velocity. Here it is given acceleration is uniform. It means you have to use all that three equations of motion which is valid for uniformly accelerated body. You write down all these three equations. First equation of motion is what? V equal to U plus AT. Second equation of motion is S equal to UT plus half AT square. And third equation of motion, V square minus U square equal to 2S. These equations of motion are for a uniformly accelerated body. Here it is given motion is uniform acceleration. So first you have to find acceleration. In first part you have to find acceleration. What is given? Initial velocity, final velocity and time, and you have to find acceleration. Which equation of motion you use? This first equation, V equal to U plus AT, right? V equal to U plus AT. From here A equal to what? V minus U by T. Okay, and V is given 72 km per hour. You have to convert this into meter per second and this time minutes also into second. So this 5 minutes means 5 into 60 second. It means 300 second, right? And this 72 km per hour. It means you have to convert this into meter per second by multiplying with simply in 1 kilometer 1000 meter, in 1 hour 3600 second. When you divide 1000 by 3600, simply get 5 by 18. So you just multiply this by 5 by 18. You get how much? 20, because 18 1 ja and 18 4 ja. So this is 20 meter per second. Okay. In this way, you put these values. V is what? 20. U is 0 and time is how much? 300 second. You get 20 by 300, right? This cancel 2 1, 2 15, 1 by 15 and 1 by 15 means You simply write this one, you convert it to decimal also. Simply write 1 by 15 meter per second square is the acceleration. And in second part, you have to find distance traveled by the train for attaining this velocity. In second part, you have to find distance. And to find distance, you have to use any one formula. Here also S, here also S. But what is given in the question? You know initial velocity, acceleration also you know, and T you have to, T is also given. So which formula is easy to use? Yes. Okay, I will use this one. It's very simple. V square minus U square equal to 2AS, right? Here V square minus U square equal to 2AS. And from here S becomes what? V square minus U square by 2A. Okay. What is V here? V is 20. V square means 20 square minus 0 by 2 into what is A here? A is 1.1 by 15, right? So after solving this one, 20 square means 20 into 20. And you take this 15 in the numerator by 2, right? This 2 1, 2 tens are cancelled, 15 to 30, so 300, right? And then 10, 3000 meter. 3000 meter means 3 kilometer. Okay. So you get displacement is 3 kilometer. In this way, you find acceleration displacement by using equations of motion for a uniformly accelerated body. Okay. I will take one more next example, that is example number 8.6. Okay. Next, 8.6. Page number 109, example number 8.6, right? In this question, it is given that a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. It means this car has some acceleration and its velocity changes from 18 km per hour to 36 km per hour. In this question, initial velocity is given 18 km per hour. Final velocity is given how much? 36 km per hour. In how much time? Time is given 5 seconds, right? Calculate the acceleration and the distance covered by the car in that time. Okay, again you have to use these equations of motion. In first part, you have to calculate acceleration. Again, initial final velocity is given, time is given. You have to use this first formula, first equation of motion. V equal to U plus AT. From here, A equal to V minus U by T, right? Time is in second. You convert this initial velocity kilometer per hour into meter per second. So you just multiply 5 by 18. It becomes 5 meter per second. Again 36 into 5 by 18. This becomes 10 meter per second. Okay. In this way you put these values here. V is what? 10. U is 5. Time is again 5. 10 minus 5 is 5 by 5. 1 meter per second square is the acceleration produced in the body. Now second part is distance covered by the car in that time. Okay, again you have to find distance. Then again which formula use? Anything. Is this formula you can also use, this formula you can also use. Okay, this time I am going to use this formula. S equal to ut plus half at square, right? So what is u here? U is 5. Time is how much? 5 seconds. Plus half, acceleration is 1 and time is again 5, so 5 square. This 5 into 5, 25 plus again 5 square is 25 by 2. You solve this one. 25, take 2 LCM. 50 plus 25 means 75 by 2. It means 2 3 is 6, 15 2 7 is 14, 2 5 is 10. Displacement is 37.5 meter, right? So, and you can use also this formula, v square minus u square equal to 2as. You get the same answer. You check it, okay? So, in this way, you calculate acceleration and displacement with the help of equations of motion, okay? Now, again, there is one more example. Okay, last one. Example number 8.7. Note down. Okay. Last example number 8.7. Page number 109. The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction to the motion. Here, the brake is applying. So, when the brake is applying, it means final velocity becomes 0. So, in this case, acceleration is positive or negative. When final velocity is less than initial velocity, this is the case of retardation. So, simply you take acceleration equal to what? Minus 6 meter per second square, because brake is applied here, right? Okay, in the opposite direction. If the car takes 2 seconds to stop after the application of brakes, how much time is taken by the car? 2 seconds, right? Calculate the distance it travels during this time. Now you have to calculate distance, right? So this point is important. When velocity decreases, you are applying brake. At that time, acceleration, you take always negative sign, not positive sign. Okay. Now you have to find S. So which formula use? Only acceleration as time is given, right? And also brake is applied means final velocity is 0. And you have to find S. So directly you use this formula. V square minus u square equal to 2as. No, because time is also given, right? So, okay, first v equal to u plus at. From here, we can find velocity u, right? So, v equal to u plus at, and from here, v is what? 0, right? U you don't know. A is given minus 6 into time is given 2. So, from here, u equal to how much? 6 into 2, 12 meter per second. Now you get initial velocity 12 meter per second, and you have to calculate S. So V you know, U you know, A also you know. You can easily find S by using this equation. V square minus U square equal to 2as. From here S is what? V square minus U square by 2a. Now what is V? V is 0 here. U is what? 12, right? By 12 whole square. U square is there. 2a. A is how much? Minus 6, right? So when you find this one, 12 square means 144 minus by 6 into 2, 12. So minus 12. Negative, negative cancel. 12 again, 12 is 144 meter. In this way, you calculate distance. So, these are 3 examples. Okay. Now, there are many questions given in the exercise of this chapter motion. I will solve all these questions after completing this chapter. Right? So, with this, I am going to end the class. There is one more class for this chapter, last part. In that one, I will discuss about uniform circular motion, and then we will solve some numericals based on that one. Okay, students? Up to then, bye-bye. Thank you.